we're doing. So we're solving applications now, kind of. Solving trig functions, but we're using that for something other than just for the fun of it. Alright, so this is chapter 14.3. Continuing really solving triangles. Okay, we're solving triangles, right triangles. This is right triangle trigonometry. All right, so let's get our functions up here. Cosine is defined as what?
1 over.
Careful. Think of a right triangle. What you were saying is not wrong, but it's not what we're going for. Yeah, adjacent over hypotenuse. It's a ratio. All of these trigonomic functions are simply ratios. What's the sine of an angle? And the tangent is what?
Opposite over adjacent.
Opposite over adjacent. And then we have our reciprocal functions. So we have secant. Notice, see, that's how I remember that this is related to cosine. The secant of an angle, I flip this. The cosecant of an angle, I flip that. And the cotangent of an angle, I flip this. Alright, so let's have a triangle. Let's say that I have a hypotenuse of, well, let's not have the hypotenuse. Let's say I have this side is 4. Let's say this side is 2. Yes, that's good. 2. I like that. And this is triangle A, B, C. And let's say I want to find the sine of A. In order to find the sine of A, what do I need first? Yeah. So basically, I'm going to have the sides of a triangle, but I won't have all of them. I use Pythag to find the missing side. Okay, so I'm going to use Pythagorean's theorem. A squared plus b squared equals c squared. So 2 squared plus 4 squared equals our hypotenuse squared. So I have 4 plus 16 equals 8 squared. I have 20 equals 8 squared.
2 root 5.
Yep. I square root 20, and then, yes, that is 2 root 5 after we simplify that radical. And we do want to do that. All right, so this is, now we know this. 2 root 5. Sine is opposite over hypotenuse, so 2 over 2 root 5. We can cancel those, so 1 over root 5. Can I leave it like that? No. I rationalize. So to rationalize, root 5 times root 5, like this. So root 5 over root 5 over 5. Okay, so that's the sine. Cosine. What's the cosine of A? 4 over 2 root 5. And then again, I can cancel those. So I have 2 over root 5. Can I leave it like that? No. So I rationalize. And I get 2 root 5 over 5. Alright, so that's the cosine. And I can erase this Pythag, right? How about the tangent of our angle? What's that?
1/2.
Yeah, it will be 1/2. 2 over 4, opposite over adjacent, so 1/2. Okay, now if I want the cosecant of A,
2 root 5 over 2.
I'll take this and flip it, right? But why not, so I had this step right here. Why not just flip that step? Because it's a little bit more reduced. So root 5 over 1, so just root 5. How about secant? Yes, I can use this step, flip that step. It's 2 root 5 over 4, but that's not reduced yet. This one's the reduced step, right? So if I flip that step, root 5 over 2, and I don't have any reducing to do. And cotangent of A, flip that step, that's the reduced step, 2. Okay, so any questions on how we did that? No? Okay. We aren't solving triangles yet. We just need to make sure we can get the missing parts of a triangle using Pythag and understand each of these steps. Okay? Give me a moment to finish writing that. Okay, we good? Leave the bottom. All right, I'll leave the bottom. Okay. All right, so the situation that we might have is maybe I tell you, all right, the secant of some angle is 5. The secant of some angle is 5. And I want you to find sine of that angle, cosine of that angle, tangent of that angle, and cosecant of that angle, and cotangent of that angle. Basically, I give you one of the trig functions, and I want you to find the other 5.
So we're just working backwards.
Yeah, kind of, yes. So here's what we need to do when we have a situation like this. And sometimes we're given more information, like you might be told it's in quadrant 1 or quadrant 2, quadrant 3. And what that's telling you is what the sign is of that, or by sign I mean if it's positive or negative. So we'll do an example like that in a moment, but for now we're just going to assume quadrant number 1. So quadrant 1. So everything's positive. Alright, so what we're going to do in this case, we're going to draw our right triangle first. And we're going to use this information to fill out the missing parts. So I have my right triangle. And secant is defined as, well, secant is, let's see how we can think of this. Secant is 1 over cosine, and the cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So hypotenuse over adjacent, that means my hypotenuse is 5 in my adjacent side. Now where's A? Well, it doesn't matter, so I just put it somewhere. I'll put it right there. And adjacent, well, my denominator is a what? A 1. So this is 1. Now I realize that this is not drawn to scale, but it doesn't matter. I'm just using that to help me set this up. So I used this information to go ahead and set up my triangle. I am missing this side. So how do I get that side? Hypotenuse. So 1 squared plus this side squared equals 5 squared. So 1 plus x squared equals 25. Subtract the 1. X squared is 24, which means x, when I take the square root of this, is going to be 2 root 6. Any questions how we get 2 root 6 there? We good? Okay, so this side's 2 root 6. Alright, what's the sine of our angle? I guess this should have been named theta, right? So what's the sine of theta?
2 root 6 over 5.
Yep, 2 root 6 over 5. And what's the cosine of our angle?
1 over 5.
Yep, and what's the tangent of our angle?
2 root 6 over 1.
Yep. And what's the cosecant of our angle?
5 over 2 root 6.
Then I'm going to have to rationalize that, so that's going to equal 5 root 6 over 12 after we reduce. Because I'm going to multiply by root 6 over root 6. That gives me 5 root 6, and then root 6 times root 6 is root 36, which is 6, and 2 times 6 is 12.
Wow.
Alright, cotangent. Flip this one, right? So what do I get?
1 over 2 root 6.
1 over 2 root 6. I multiply top. I rationalize this. So I get root 6 over 12. Okay? So these are my answers. Okay? So what's our strategy? If I'm given the ratio of a trig function, I can go ahead and draw a triangle, a right triangle, and start filling in the missing pieces to get all the rest of them. What I don't want to do I don't want to cheat. What do I mean? I don't want to do, like say I told you the cosine of an angle is 1/5. What I don't want to do is do, well, inverse cosine that and get an angle, because then I'm going to have rounding errors. So I want to avoid those. Alright, let's do one more. This time I'm going to have us in a different quadrant. Let's say the cosine of an angle is negative 0.4. Yes, that's a decimal, I realize that. We might be given a fraction, we might not. And I'm going to tell you this is in quadrant number 2. Well, cosine's negative in 2 quadrants, right? It's negative in quadrant 2, in quadrant 3. And yes, it will be important that I tell you this because sine could be positive or negative. So since we're in quadrant 2, we know that sine's positive, which also tells us that tangent is going to be negative. And we're going to find the other 5. So I'm going to draw my right triangle just to help me to find the rest. Cosine is defined as adjacent over hypotenuse. So I have a decimal in this case. So I can deal with this decimal 2 ways. I don't care which way you use, it doesn't matter. I could say that this, now I'm going to leave this, I'm going to do the absolute value, and I'm going to use the fact of which quadrant I'm in to determine the values of my other functions. I could fill in like this. What's the denominator here? 1. I could fill it in like that and do Pythagorean's theorem using decimals. That's okay. I don't care if you do that. You'll get the same answer as we're going to get doing the other way. I technically like this way. I like saying that, well, 0.4 is 4/10, and I change it to a fraction and reduce that fraction. So I get 2/5. So now my adjacent side is 2, and my hypotenuse is 5. And then I do Pythagorean's theorem using that rather than decimals. So now I have 2 squared plus, I'll say that's x. X squared equals 5 squared. So I have 4 plus x squared equals 25. X squared is 21. And x is root 21. This is I think this is a lot better than decimals because we're going to have kind of weird things going on here and we'll have to estimate. So I prefer not. So I prefer, although I don't care, technically, that you use fractions instead. So if you're given a decimal, my recommendation is change it to a decimal. If I'm given a decimal, change it to a fraction. So this is 4/10, so you see how I wrote that as 4/10. Okay? Alright, so this is my angle. This is my theta. I found this side. This is root 21 by Pythagorean's theorem. Alright, so since I'm in quadrant 2, it might be helpful for you to think about this. If I'm in quadrant 2, I'm over here, put a big star there. Cosine's negative, sine is positive, and tangent is negative. Alright, so what's the sine of my angle? Yep. Alright, I already have cosine. What's the tangent of my angle? Yep, root 21 over 2. What's the, let's do secant of my angle? Well, I might want to come up to here and say, well, that was, I rewrote that as negative 2, what? Fifths, right? So, it's negative what? 5/2. I have to flip that one. Also, we need to come back to tangent. This is wrong. Why is this wrong? No,
it's negative.
It's negative. Okay, it's negative. I need to account for which quadrant I'm in, right? I'm in quadrant number 2. So tangent is negative in quadrant 2. So watch your signs. We also have cosecant of our angle, which is going to be what? 5/√21. So that's 5√21 over 21 after I rationalize. And finally, cotangent is
Come on. Two.
But we do need to be careful, negative, and then rationalize. And we're good. So yet again, we're going to be solving right triangles. Now, we have kind of been solving right triangles here by finding these, but what we actually, our actual goal is to be able to use this math for something other than finding these. So, let's have a situation. Perhaps we have a ladder against a building, and we have Cameron is climbing up it,
Yay.
doggy style because he's afraid. And we have this building,
He's gonna fall.
and let's say that we know. Okay, we have a 10-foot long ladder, and let's say this is 5 feet from our building, and let's say I want to know, well, how tall is this building? I can use Pythag, okay? And let's say I want to know, what's this angle? So what is the angle the ladder makes with the ground? So I need to draw my ground. Here's my ground. Uneven. Okay. I could use Pythag to find this. So I did ask us that, so let's go ahead and find that. So we have 10 squared equals 5 squared plus our building squared. So that's 100 equals 25 plus b squared. We'll subtract the 25 and get 75 equals b squared. We take the square root. Now I split that up. That's going to be 5 squared times 3 by prime factorizing, so I get 5 root 3. Alright, so this side's 5 root 3. So I answered that question mark. Now let's answer this. Now I want to avoid using things that I calculated, and I calculated this side. So I'm going to use only the given information if possible. That's that 10 and this 5. So using my trig functions, and by trig functions I mean our basic 3, sine, cosine, and tangent. Of those 3, which could I use using these two sides? Well, with respect to this angle, this side is the hypotenuse, and this side is adjacent. So I have adjacent and the hypotenuse. So of these 3, which is adjacent and hypotenuse? The cosine. So cosine of my angle is 5 over 10. And now, to solve that, I do inverse cosine. And I get...
Okay, change it to 1/2. That doesn't matter.
It doesn't matter. I could change it to 1/2. But in the end, it doesn't matter. What's the inverse cosine of 5 over 10?
$60.
60 degrees. So this ladder makes a 60-degree angle with the ground. And that's the answer.
The word fall.
That answers this. Okay? So now, rather than write out word problems, let's just see, maybe I give you this. This is 40 degrees, and this is 6. Let's find x and y, and z. Okay, so that's called solving the triangle. We're given basically if we have, in any triangle, even if it's not a triangle, we'll find this later. But in any triangle, if I have 3 pieces of information, as long as they're not all angles, I have to have at least one side. But if I have 3 pieces of information, then I can find all the other 3 pieces. So let's find z. That's the easiest to find first. How many degrees are in a triangle?
180.
180. So z is this other angle right here. So I can do 180 minus 90, right? I'm minus this 90-degree angle, minus the 40, and I get 50. So that gives me z. Okay, so that one was easy. Now I calculated that, so if I can avoid using that, I will. Let's find x. x is opposite, and this side is,
Adjacent.
so I use tangent. Tangent of what? 40. What goes at, see, in any trig function, sine of an, what goes right here?
Angle.
An angle. Cosine of an
Angle.
angle. Tangent of an
Angle.
angle. So what's my angle?
40.
It's 40. So tangent of 40 equals x over 6. Okay? Now you can put tangent 40 in your calculator at any step you want. I like saving it to last. So I'm solving for x, so I multiply both sides by 6. So I get x equals 6 times the tangent of 40. X is alone, so now I go to my calculator and I go ahead and type that in. And what do we get? To the nearest tenth.
5.03.
5.03. Okay, that's the nearest hundredth. Good enough. Okay? Alright, let's find y. Now I'm going to avoid using anything I calculated. I calculated z and I calculated x. So I'm going to just use this 6 and this 40. So this 6 is adjacent to my angle and this y is
Hypotenuse.
hypotenuse. So what has to do with adjacent and hypotenuse? Cosine. So I'm going to do cosine, what?
40.
Equals
6 over y.
6 over y. Now what do?
Multiply by y.
Multiply by y. Okay, I need to clear my fraction. So I have y times the cosine of 40 equals 6. Y is not alone. I need to do one more step in this case. Y equals 6 divided by
Cosine 40.
cosine 40. So I put that in my calculator and get y is
7.8.
7.8 to the nearest tenth. Okay, so as a quick check of our work, y is the hypotenuse, so I expect it to be the longest side. Of the three sides it is. And I expect to have 90 degrees in here. Okay, we calculated z as 50, and we do. So we have all our answers. Boy, this is taking a little bit longer than I wanted. Let's do one more. Do you want to find sides or angles?
Oh, okay.
We don't care.
It's at the E box.
Let's do
Box.
some.
No, don't call them balls, that's what we did.
Wow. X, Y, Z. Okay, so X is a side. Now we can find X by what?
Bad thing.
Pythag. So we'll go ahead and do that. So X squared plus
5 squared.
equals 14 squared. Alright, and yes, 25. What's 14 squared?
190.
Now we subtract our 25. And we take the square root. We can leave a square root of 171. And if we're told to round to the nearest tenth or hundredth or whatever, we go ahead and do that. We found x. Alright, a brave soul set up finding y.
You have to do,
You're right.
Right.
Y cosine.
yeah.
This side is the what?
Hypotenuse.
And this side is,
Adjacent.
so cosine of
Y.
y, remember an angle goes right here, equals,
5 over 14.
am I ready? What do I do next?
Inverse cosine.
Inverse. If I want the angle, I do an inverse. So inverse cosine of 5 over 14.
69.1.
Alright, and set up finding z. Now we could, typically we would avoid using this this calculation, but we could do, because we know we have to have 180 degrees. That's a must. We could do minus 69.1 minus 90. And to get our answer, what do we get?
20.9.
Okay. 20.9 you said? But just for practice sake, let's do what Jarrett was saying. We want z that's opposite over hypotenuse. Let's use sine. So sine of z is 5 over 14, and then inverse sine of
You get 20.9.
14, or 5 over 14, and yes, we should get the same thing.
So,
0.9.
so they're both 20.9?
Yeah.
Well, I calculated z
Twice.
twice. I did it one way by using 180. Since we must have 180 degrees in the triangle, once I have two angles, I can use them in subtraction to get the other angle without much issue. We just did it another time just to emphasize the trigonometry. All right, that's good. All right, so we're done with that today.
Like,